Bismillah Rahman Rahim. Assalamu alaikum. I am Dr. Mumtazul Islam with a new topic about dental materials. The topic of today's lecture is elastic impression materials and synthetic elastomers. These are synthetic. Till now, we have studied the rigid impression materials, reversible hydrocolloids, and irreversible hydrocolloids. And now we are studying elastic impression materials that are synthetic elastomers. So if we go to the history, so synthetic elastomers were developed for industrial applications, for paints, for coatings, for other things, for prevention of metals through rusting, etc. Now, application in medicine and dentistry soon realized, and as dentistry needs impression materials, so as impression material, dentistry welcomes these products and these materials. So what are the reasons for their acceptance? That they have good tear resistance and dimensionally stable, which are the main disadvantage of hydrocolloids. Either hydrocolloids are of a reversible type or of irreversible type. Now, types. Usually, mainly there are three types, which are classified into four types. But another material also present there, so which is a combination of the two materials. So it is also designated as a fifth class. But mainly there are three types. But for the sake of your own knowledge, you can say four types. Number one is polysulfides. Number two is silicone rubbers. Silicone rubbers have again two types: condensation type, curing type, and silicone rubber of addition curing type. Depends upon the reaction of their curing or polymerization. And polyether. And the fifth one is the polysulfide and polyether. Sorry, polyvinyl siloxane ether. So this was the again the combination of polysulfides and polyether. Classification: standard for dental elastomeric impressions according to ISO are 4823. ISO 4823 is the standard for dental elastomeric impression materials. Its consistency based on four categories starting from 0, then 1, then 2, and then 3. Categorization by pressing 0.5 ml mixed material between two plates and applied by a force of 1.5 Newton, and the average diameters recorded defines the viscosity, and upon that obtained diameters and the viscosity, they were classified into 0 to 3 categories: 0, 1, 2, and 3, in four categories. So if we have a look, that type 0 is very high consistency, which is also called as putty like. Minimum no diameter, maximum is 35. Then high consistency type 1, it again have maximum 35 millimeter diameter. Medium consistency for medium body, the 0 is putty like, 1 is heavy bodied. The medium consistency is also called as medium bodied. It have a minimum diameter 31 and maximum of 41. And type 3, low consistency light bodied material, having minimum 36 millimeter diameter on pressing between two plates, and maximum is indefinite, not mentioned. So if we see, then overlap between different consistencies is evident. Materials producing a diameter of 31 to 34 millimeter, usually categorized as 0, 1, and 2 types. So manufacturer decides that in which category a material should be placed. Terms like soft putty type 0 again further complicates this situation. Solution. And what we have to do? Solution with us is clarifications come through usage. When we use, we will be clear enough about these materials. Type 0 and 1 can be used with type 3 material, and type 2 material used alone in monophase, as they are also called as monophase elastomeric materials, because type 0 having high consistency, 1 medium consistency, we can see putty like, heavy bodied, and it is medium bodied too, and then comes the light body. So type 0, 1 used with can be used with type 3 materials, and type 2 materials can be used alone. 0 is putty, heavy bodied, 2 is medium bodied, and 3 is light bodied. Now, the first material is polysulfides. Polysulfides are the most primitive materials. Now, rarely present in market, especially in Pakistan. Presentation, already described how they are presented in market. Presentation is two paste system, then dispensing through soft tubes like toothpaste like pastes, toothpaste like tubes. One tube having base and the other having catalyst. There are there are other names of polysulfides also there. One is mercaptan and the other one is thiocol. So, composition of polysulfides. In base paste, polysulfide prepolymer with terminal and pendant thiol groups. Now, what are the pendant and terminal thiol groups? Pendant. Can anybody? These are the, if these are groups, so and these ends are terminal, and if a group is present here, then it will hang like a pendant in you can say, if this is like this one, these two ends are, these two ends are terminal ends, and if another end is present here like this one, then what we can say, it will be a, it will be a pendant. Sorry, I am doing it with my own hand, so drawing is not as good. So these are the terminal ends, and this is the pendant end. Pendant mean, you can say, the hanging one. This forms polymerize after polymerization, a rubber. After polymerization and after cross linking, it forms rubber, which polysulfide prepolymer with terminal and pendant thiol groups. Plasticizer used in these are di and butyl phthalate, di and butyl phthalate, and these are to control the viscosity. Then inert filler, possibly chalk, that chalk with which we uh, are used to write on the blackboard, or titanium dioxide. And the plasticizer, sorry, is used for controlling viscosity, and the fillers used for viscosity and to provide body controlling viscosity and modify physical properties of the material. Catalyst space, lead contains lead dioxide or other alternative oxidizing agent. This is again the active ingredient which react with thiol group and produce setting or polymerization. Initiate. Now, sulfur, it also involved in setting reaction like lead dioxide. Inert oil, normally paraffin or di and butyl phthalate, paraffin or paraffinic type, and they form a paste with plumbum oxide and sulfur, or lead dioxide, sorry, and sulfur. Mixing. Mixing can be commenced through a spatula. This is a spatula. This is a mixing pad, and these are two tubes, catalyst and base. They are extruded onto the paper pad and mixed with this. spatula. Now, if we see the structural formula, you can see these are the terminal ends and this is the pendant group. Is it clear? These two are the terminal ends or terminal groups SH, and this is the pendant group. Now, viscosity. There are three viscosity depending upon the filler content available. Number one is light bodied, number two is regular bodied, and number three is heavy bodied. But if we are going to according to classification, then the heavy bodied, number one, regular body number two, and light body number three. Base and catalyst paste. Base paste. Now we see that what is present in paste in each type of paste. One is base paste and the other one is catalyst. The base paste consists of un of consistent sorry of a polysulfide prepolymer, plasticizer, and inert filler. It is white in color, usually due to the filler, that is titanium dioxide or other one. Unpleasant odor of thiol groups is a disadvantage, major disadvantage. Can you imagine what will be the odor of thiol groups? Hydrogen sulfide, a very pungent smell. Usually, this unpleasant odor is present in our sewage system. A closed sewage system have the hydrogen sulfide gas. Then the catalyst base, it derives its color from the oxidizing agent, that is lead oxide, which is dark brown. If we can see, it is a dark brown color, although it seems to be look like black, but it's a dark brown. So again, the mix which we have to prepare from these two pastes should be streak free, so as to take maximum benefit and to make sure that all the material is mixed thoroughly. Streak free, I have explained in my previous lectures that why streak free and what is streak free. Pre-polymer terminal and pendant thiol groups obviously reacts with lead dioxide. Then chain extension and cross linking occurs. How? We can see chain extension. It is one chain, then comes the other one, then comes the other one, then again comes another chain. I am giving some space for your understanding, that you can understand that how these extension occurs. So as the polymerization commences, the chain lengthening or chain extension occurs. and side by side cross linking. Yes, like this occurs. So when this happens, it means polymerization is under its way. There's no space in between, they are all linked up together. So chain extension and cross linking occurs through condensation polymerization reaction will be discussed in another chapter, and obviously you people have a somewhat idea about condensation polymerization reaction. For the sake of your knowledge, kindly keep it in mind that in condensation polymerization reaction, production of one molecule of water or alcohol as a byproduct occurs. Now the chain extension increases viscosity. As you can see, if these chains formed in a solution like we have discussed in the previous chapter where converts into the gel form. So these chain extension increase the viscosity and the cross linking. These cross linking. Sorry. Now chain extension increases viscosity while cross linking produces elasticity. As it was previously described in our chapter about impression materials. One water molecule at each stage, how it will be produced. You can see that these are the prepolymer of polysulfides with catalyst, which is lead dioxide. When these two groups become attached with each other, these two or these two, these two or these two hydrogens plus one oxygen and two hydrogen plus one oxygen, a hydrogen molecule will be obtained as one from this one water molecule from this and the other from this. So from two molecules, a single water molecule obtained as a byproduct. Now setting starts immediately during mixing. As soon as we start mixing, setting starts. Setting of the material. Viscosity increases gradually. Elasticity develops more slowly. Setting time is 10 minutes or more, especially for light bodies, because light bodied have no fillers. So more material to react with each other. So it will take more time. Excellent tear resistance. It can withstand 700% tensile strain before tear. Again, it is a huge difference before polysulfide and other materials. Viscoelastic, again, as described in previous lectures, what is a viscoelastic material? After compression or stretching, recovery is slow. And impression should be removed with a single swift pull. Already described in the chapter of alginate and agar that we have to use a snatching action for pulling out the impression. High viscosity, low flow, no fine details. If viscosity will be high, flow obviously will be low, so fine details will not be recorded. And dimensional stability affected by setting reaction and continues after the apparent setting time, like the previous one which we have studied. Which one? The alginate. Evaporation of the byproduct. Byproduct evaporate. One water molecule easily can be evaporated. High filler content and less reactive groups produces less byproducts because reaction is less. Now, if we see the filler based properties, if the filler content is increasing, then light bodied having less or no filler content. If filler content increased, then regular bodied, and if again it is increased, then we have heavy bodied. Viscosity in light bodied is less but increased due to the high filler content in regular bodied and heavy bodied. Setting contraction also decreased due to less number of reactions. Thermal contraction also decreased because of the filler. And dimensional stability, it will increased due to the presence of filler content because filler have its own weight, mass and space. Toxicity issue. Lead is well known for its toxicity, obvious, subtle, and it is considered to be harmless in impression materials due to why? That it has short exposure time in patient's mouth and it is hydrophobic. All of you know about hydrophobic, that mixing with saliva is less. It pushes the saliva away from it. Lead-free polysulfides are also available nowadays, but not in Pakistan. Clinical application, it is usually used in two viscosities, high and low. Both can be used as custom made tray. Sorry, both viscosities can be used in custom made tray. The custom made trays are also called as special tray. These are not of stock tray type. These are custom made tray and can be used in less moist condition due to moderate hydrophilicity. They can show hydrophilicity, a moderate type of. Not true hydrophilicity, but a moderate hydrophilicity. So they can be used, these materials, in less moist conditions. Commonly used for crown and bridge impression. These material, not hydrocolloids, these which materials we are studying? Elastomers. Elastomers are used commonly for crown and bridge impressions. One stage procedure through syringing and loading in tray for simultaneous setting is routinely employed for polysulfides. Light body material flows well. One stage procedure that at the same time syringing over the prepared tooth or teeth and the remaining material loaded in the tray and impression taking in a single attempt. Now it is a picture in which we can see this yellow color. Yes, this one. This is the light bodied material. Yes, this is the prepared tooth, and this one is the heavy bodied material, and this dotted area is representing our impression tray. Pouring the cast after removing debris and disinfection of impression. Disinfection and removing debris were discussed already in previous chapters. Model should be poured after some time to facilitate or to, yes, to complete the viscoelastic property or to return to its original position due to the which was produced due to the stress which was produced by undercut area or any other or pressure or any other uh, parameter which was faced during taking the impression. Cast should be poured before 24 hours. The cast must be poured before 24 hours, not to take the, as it is a plastic type of material, it become elastic. It is elastic, but uh, having a fine uh, piece of impression which can be considered as a plastic type of material. So not to save this for days and weeks because it can flow plastically. So it should be poured before 24 hours. Electroplating, which we have studied in our agar in the chapter where we studied agar, that electroplating and epoxy resin dye material cannot be used for agar, but here surface of impression can be electroplated. Copper sulfate electroplating bath is used for surface of impression for electroplating. Epoxy resin dye material then used for the rest. Surface is electroplated and then the epoxy resin dye material used for the rest. These metal outside, electroplated material and plastic epoxy resin dyes are expensive but very hard, not prone to damage. So these were used for multiple tasks over the same die. When we have to do multiple tasks and we have a single die, so with which was uh, for which we have taken impression from the with the polysulfides, we can electroplate it with copper sulfate electroplating bath, and then epoxy resin dye, a hard dye will be formed, and mm, we can do multiple tasks over a single dye. Allergy, obviously some patients are allergic to polysulfide as these are rubbers and latex gloves. Usually we are using these latex gloves, these yellow type of gloves. These may elicit allergic reactions to some patients and to some doctors also. Now, the silicone rubbers, the condensation curing, the other type, polysulfide are finished. Presentation, dispensing, and ingredients. If we consider these three things, two pastes or liquid paste, fixed number of drops are used if liquid paste system is available. Mixing on glass slab or paper pads, which we already seen in polysulfide. Base hydroxyl terminated polydimethyl siloxane. These were liquid silicone pre-polymer. Here the pre-polymers are polysulfides. There the liquid silicone pre-polymers. Excuse me. Now, base is hydroxyl terminated polydimethyl siloxane, that is liquid silicone pre-polymer. Alkyl silicate tetraethyl silicate is present in reactor paste. Tin compound, that is dibutyl tin dilaurate. These are used as catalyst. Composition, condensation curing, rubber material, silicone rubber. Paste has hydroxyl terminated polydimethyl siloxane, liquid silicone polymer. It goes cross linking, undergoes cross linking, form rubber, inert filler such as silica. That is not, this word is not insert, it is inert filler. And again, filler provides body, control viscosity, and modified physical properties. Liquid alkyl silicates such as tetraethyl silicate, and this acts as cross-linking agent already described. Tin compound such as dibutyl tin dilaurate, it is a catalyst. Types, similar to room temperature polymerization silicone, which you are using in your household environment. The silicones, these are soft liners. Then light bodied, regular bodied, heavy bodied, putty, zero, paste of very high consistency, all have been described earlier in this chapter. Now setting reaction. On mixing, reaction starts immediately, like polyether, polysulfides. Again, the terminal hydroxyl group of prepolymer chain reacts with each other. Then cross-linking agent under the catalytic activity of 10 compound starts. Each cross-linking agent can react up to 4 prepolymer chains, and this causing extensive cross-linking, which increase viscosity and rapid elasticity. And if we consider here in polysulfides, each reaction stage produces one molecule of water. Now, in this, each reaction stage produces one molecule of ethyl alcohol. Sorry, I want to show you this ethyl alcohol. Now, each reaction stage produces one molecule of ethyl alcohol. This was the uh, part of slide which was not shown to you people, so I have corrected this. Then properties: short setting time with early elasticity development. It is very hydrophobic. The the polysulfide was moderate hydrophilic and hydrophobic, but it is very hydrophobic, and it repelled by water and saliva, or uh, vice versa. It repels water and saliva. So it is essential to dry the area to be recorded. If not, blowholes will be obviously seen in the impression. Blowholes mean cavities in impression. So if we not isolate the water and saliva, or dry the area from where we are going to take the impression, then due to its hydrophobic nature, blowhole will be present in our impression. Now set material shows 300% extension, which is much less than polysulfides. So what is extension which polysulfides gives us? Now I have explained. Now it's your turn that you should remember that. Fillers dependent properties. Obviously, putty consistency, that is 0, is also available. Filler dependent properties explained already. Lower thermal and setting expansion values than other elastomers. It has low thermal and setting expansion values than other elastomers. Lesser than other materials are their dimensional changes. Continued slow setting and shrinkage occurs. Why? Due to the cross linking and production of byproduct and evaporation of ethyl alcohol. Ethyl alcohol readily evaporates than water. Loss of weight due to evaporation of byproduct is another factor which uh, results in dimensional change. Regular bodied condensation silicons are slightly greater than regular bodied polysulfide. What is this? That they have water and these having uh, byproduct which is sorry ethyl alcohol. So regular bodied condensation silicons are having greater dimensional changes than regular body polysulfides and smaller dimensional changes than alginates. Model should be casted immediately. Toxicity issue again with this considered essentially non-toxic in spite of having a heavy metal catalyst is present. Again, the reason was given by manufacturers or other authorities is that it is present in patient mouth for few minutes and extremely hydrophobic, so nothing to worry about it. Liquid component is extremely hazardous. Accidental splashes cause irritation and blistering of eyes, so be careful. Applications, crown and bridge impressions can be taken through this. Partial and complete denture impressions can also be taken with these, but nowadays a gradual decrease in their usage is obvious. Now comes silicone rubbers, that is addition curing type. Presentation is again two pastes, each paste having three polymer and fillers. One paste contains a polydimethylsiloxane, the polymer, same, with some methyl groups replaced by hydrogen. Other paste contains some methyl groups replaced by vinyl group. Catalyst is added in any one paste. These are usually platinum containing compounds. That is why their cost is somewhat high. And chloroplatinic acid is its catalyst. Four viscosities are available. Streak free mix as previously described. Auto mixing cartridge format is also available. We can see these material in our operative or in prosthetic department. Mixed material can be loaded into a tray or directly into the mouth. Electrically driven mixing devices are also available for 20 impressions. Disadvantages of auto mixing are that these are they uses disposable nozzles and more wastage of material is there due to the uh, material which will be left in the nozzle after mixing. Setting reaction: platinum catalyzed addition reaction starts on mixing. Again, same. Cross linking between two types of siloxane prepolymers is obvious, and no byproduct is produced. As in other materials, byproduct in one water and in other, you know very well, but in this no byproduct is produced. But hydrogen gas production is reported due to the reaction of platinum with moisture. So cast should be delayed for pouring to prevent pitting. And this pitting, the bubbling out of is due to the bubbling out of the hydrogen gas. Properties similar to condensation silicons. Adequate setting characteristics, have a good tear resistance and near ideal elasticity. Combined use of putty and light bodied provide excellent results already described. Little or no byproduct is there, so they are dimensionally very stable, and also they are hydrophobic, repelled by moisture, so the blowholes are obvious if a moisture is there in the field of impression. Now, hydrophilic or less hydrophobic. This is a controversy type of thing. Is as there is a problem of blowholes, which is addressed by incorporating surfactants. Surfactant, all of you know, as all people are going to wash their hand in this corona era, that surface acting agents, the surfactants. So these surface acting agents, they take away the lipids. So they also dries somewhat. They the surface becomes somewhat drier. So these surfactants are used to reduce the blowholes. Now new materials are described, sorry, and are introduced, which are described as hydrophilic addition silicones. But as the material has its own hydrophobic properties, actually these are less hydrophobic. So the surface acting agents, surfactants, should be coated through sprays on tissues that are going to be recorded. So this improves the impression and also the compatibility of gypsum products. Clinical applications of condensation, addition silicons are crown, bridge, and denture manufacturing for the impression. Medium viscosity material for monophase impression. Monophase impression already described. Accuracy is not as good as two viscosity technique shows. Two viscosity technique also described in previous sections. Heavy bodied in combination of light body is a routine practice. So as we are going to use two different materials, and as we have discussed in impression plaster, that color contrast is a parameter for differentiate between two materials. So light bodies bodied and heavy bodied differs in color so as to their recognition, that which one is the light bodied and which one is the heavy bodied. Problem with high viscosity material when used with stock tray. These are problems when stock trays are used for taking impression with high viscosity material. Plastic, if the tray is plastic tray I have shown in my other lectures, you can see the pictures. The plastic tray flexes outward. On the recovery, it comes back and distort impression. This is the problem. So what will be the solution? Easy solution is not to use the plastic trays. Nowadays, metallic trays are available there. So use the metallic trays and use two-stage technique with a spacer. It also provide a good result. Two-stage technique with a spacer. First impression will be taken with a heavy bodied with a spacer, usually a polythene sheet. After taking the impression, remove the impression and also remove the polythene sheet, the spacer, and then pour the light bodied over the impression or change over the teeth and take the impression with that light bodied impression material. So these materials are markedly hydrophobic and usually produces blowholes. And what will be the solution? Only solution is to dry the area simply. The surface acting agents, which are also called as wetting agents, added by manufacturers can also be used, which and they are also added by manufacturer into the material. So you have not to worry about this, only to dry the area. Otherwise, aerosols are available, which are containing wetting agents, and these are also supplied, also in the market, present in the market. So you have to spray the aerosol containing wetting agents and then to take the impression. Now, the platinum catalyst easily poisoned and it inhibit the setting due to these factors: plasticizers in the rubber gloves, rubber dam, and powder, hemostatic agents based on ferric salts, freshly placed methacrylate materials, composite compromise and light cured glass ionomer cements. These are also having the methacrylate material. So if these things are present, First of all, avoid rubber gloves. Use nitrile or vinyl gloves. Remove the rubber dam. Use powderless gloves. And for others, not to use hemostatic agent based on ferric salt, or if you have used, then delay the impression for a day if fresh fillings are placed. Protection and disinfection is another issue. Never ever touch a patient or a material with unprotected hands. Always wear gloves. These can induce contact dermatitis if used without gloves. Disinfection with sodium hypochlorite is sufficient, and more rigorous disinfection with glutaraldehydes can be performed. And this is the end, but now we will start polyether. And now the polyether, basically of third type, and if we consider the uh, others as condensation and um, addition type of silicones, then it will be the fourth one. Presentation is of two types, toothpaste, contrast color, usually in regular bodied. A single viscosity is available with a diluent oil. No 0123. Base paste contains prepolymers and fillers like the previous ones, and it will be the in a large tube, while the catalyst paste, which contains reaction initiator, paste forming oils and fillers, is in a small tube. That is why the ratio of base catalyst is 8:1. So the base paste is larger enough and the catalyst paste is smaller one. Bulk auto mixed format are also available. So composition is base plate, large tube, amine terminated prepolymer becomes cross linked to form rubber, inert filler, usually silica to give body control, viscosity, and physical properties like previously. And plasticizer is phthalate, not phthalate, it is phthalate. And it's add mixing. Plasticizer. Catalyst paste, small tube have ester derivatives of aromatic sulfonic acid. Again, initiate cross linking. Inert filler, again the silica, and plasticizer are phthalate. Again, now setting reaction. A cationic ring opening addition polymerization reaction is there. Ring opening. Have you an idea? You people, any idea having ring opening? Yes, we can see this that this will be a ring. So this is a ring, and if we try to open this ring, what will happen? It will become like straight like this one. So this is a cationic ring addition polymerization, and if the other ring is open, then it will come here. And the cross links, if we see the other one again here, and cross linking in between these two, for only for the sake of your knowledge, ionized form of the sulfonic acid ester, initial source of cations in this uh, reactions. Each stage of reaction involve opening of an epimine ring and a new cation. Each reaction opens up a ring like this one. Activation, initiation, and propagation stages can be identified. These are the stages of polymerization of addition type. Two reactive epimine groups on propagation produces either chain lengthening or class linking, which increases viscosity. And you can see the activation. This is the in, um, reaction product which become activated. The which we can see the mm, addition polymerization reaction, and they become the positive and negative charged particles. There are, this is the reactive agent, and initiation starts, then propagation. This we will discuss in detail in another chapter, but for the sake of your knowledge, it is simply described here that this is the molecule activated, then the activated molecule become initiated toward the others for initiation of the reaction, then the reaction prolongs and it is propagated, and so, and this will goes on. Properties: adequate tear resistance and elastic properties are there like others. It is relatively rigid, much force needed for removal. It is the rigid of all of the materials. So it is very difficult to remove it from undercut area, if any undercut area is there. Present in single viscosity, so combined technique is not possible. So as it is present in a single viscosity, so two type of technique, one is ranging and the other one is not possible. Simply load it into the tray and take the impression. No new formulations are available with different consistencies. Now they are saying that new formulations are there, but I have not seen any uh, new formulations. Again, now all the materials are hydrophobic, but this material is hydrophilic material. So moisture control is not a problem. If there is a moisture, nothing to worry. Set material is also hydrophilic, so not to placed in a humid environment, not to cover up with the damp cloth, etc. Clinical application, monophase technique, simple. In a simple tray, you can take the impression directly. Used in areas where moisture control is a problem, is its area of application. Disadvantage is its rigidity, especially in gum recession, where gums are detached from the teeth or away from teeth. Undercut areas, already described, open embrasures and existing bridges. Existing bridges are also a source of undercut, are also a type of undercut. You can see, inshallah. This will cause extraction of the tooth or bridge with impression. You can imagine how stronger its grip is and how difficult to remove it from an undercut area. To resolve this issue, block out these areas with wax or Teflon. So block out means cover up to block the undercut areas with wax or Teflon, the same Teflon which we use in our household environment uh, for control of seepage from our mm, water supply lines, etc. But this rigidity also provides us a benefit when we are taking the impression of an implant. Yes, here the material should be tough enough for taking the impression of minute areas and minute details. Now, this is another assignment. What is an overlay impression? And also define locating impression. So, this is your assignment. We will send you the parameters or the we'll send you the details about how to uh, accomplish this assignment or how to perform or how to submit this assignment. Toxicity and disinfection, again we will discuss about each and every material. As sulfonic acid catalyst is present and it is a potential toxic material. Disinfection for 10 minutes in. Now the answer now should be from your side. Longer time water immersion causes. This is again the question which you people have to answer. General requirements of materials. ISO specification for elastomeric impression is 4823. Type 0123, if we see strain in compression, if we see for type 0 is 0.8 to 2 to 20%, for 1 is 0.8 to 20%, and for type 2 it is 2 to 20%, and for type 3 it again 2 to 20%. Recovery from deformation in percentage is 96.5% for all. 24-hour dimensional change is 0 to 1.5 for all of the four types. Detailed reproduction, width of line reproduced in millimeters. If in impression it is for 0, 0.075, for 1, 0.50, for 2 type 2, 0.020, for type 3, 0.020, In gypsum cast, 0.075, 0.050 for type 1, for 0.05 for type 2 and 3 also. General values. Polymerization shrinkage of regular viscosity material is 0.4 to 1%. Coefficient of thermal expansion of elastomeric is 190 minus 300 multiplied by 10 raised to power minus 6 degree per centigrade. For regular bodied materials, that is, sorry, 190 minus 300 is not correct. 190 to 300 multiplied by 10 raised power to 6 per degree centigrade. Both of these values are greater for light bodies and lower for others. Higher viscosity materials are stiffer than other, it is obvious. Polyether materials is much stiffer and polysulfides are less stiffer. Stiff materials use in enough thickness to compensate deformation under load. Is it clear? Now, qualitative properties. Comparison of properties of all the materials. Property if viscosity is considered for polysulfides, it available in 3 viscosities, no putty. Condensation silicons available in 4 viscosities, including putty. For addition silicones available in 4 viscosities, including putty. Polyethers available in a single viscosity, regular plus diluent plus putty. Then tear resistance for polysulfide, it is adequate. Condensation silicon, addition silicon, and polyether, it is adequate for all the 4 materials. Elasticity for polysulfides, it is viscoelastic material. Condensation and addition silicon, it is very good. And for polyether, it is adequate. Accuracy, good with special tray for polysulfide, acceptable with stock tray for condensation silicon, good with stock trays for addition silicons, and good with special trays for polyethers. Dimensional stability adequate, but pouring of model should not be delayed. For polysulfides, for condensation silicon, model should be poured as quickly as possible. For addition silicons, it is very good, but not very good. Very good mean that you have to wait because of the hydrogen gas. You have to wait for about 1 hour. And for polyethers, very good in low humidity conditions. So tear resistance, there is no test for tear resistance in the ISO standard. Polysulfides show elongation at break, that is 500% for regular bodied material and 700% for, now it's up to you that how many knows that what percentage 700% is for which material. Addition silicon gives highest value of tensile strength, that is 2 to 5 megapascal. Disinfection requirements of ISO standard is that manufacturer provide detail of a suitable method for or what of the product. This again is your responsibility to find to fill in the blanks. Disadvantages and advantages. Elastomeric materials, both polyether and addition cured silicon. They also used to record the jar relationship. But on the other hand, they record too much details from the occlusal areas. So the too much good thing becomes a bad thing. How? That the too much detailed recording then cannot be re-engaged on working models. In mouth, it is possible, but on working model, it is not possible to re-engage the occlusal surfaces. Folds of impression material does not allow seating of the casts. So this byte registration will become useless. Though it provides very good and very detailed impression. And thank you so much for a lengthy lecture. I'm thankful to you.